Good morning, everyone. Today, I am going to discuss about model building with regression. Now, here is our guide in the flow of our discussion for today. So, we are going to define regression analysis, when it should be used, how it can be computed using Microsoft Excel and Jamovie, and I'm going to show you how to report this one or the result of your data using APA 7th edition. A regression analysis makes it possible to infer or predict a variable on the basis of one or more other variables. For example, you want to find what influences the salary of people. It can be the highest level of education, the weekly working hours, or the age of a person. So in regression analysis, you are going to consider the relationship between the dependent variable and to the independent variables. So the one you wanted to predict is called the dependent variable or the criterion, and the one you use for prediction is called the independent variables or predictors. So regression analysis is used to achieve the following goals. First one is measurement of the influence of one or more variables or another variables. So say for example, what influences children's ability to concentrate? So you might be interested in what has an influence on students' ability to concentrate, and so you're going to prove that there are parameters that are positively or negatively influence children's ability to concentrate, but in this case, you do not focus, or your interest is not in predicting children's ability to concentrate. And the second one is prediction of a variable by one or more other variables. Say for example, what product is a person most likely to buy from an online store? So to be that, uh, say for example, you are a store owner, you might be interested in which product a person is mostly likely to buy, so you want to suggest this product to the visitor in order to increase the sales of, of the online store. So regression analysis has different types. So it is divided into simple linear regression, multiple linear regression, and logistic regression. So the type of regression analysis that should be used depends on the number of independent variables and the scale of measurement of the dependent variable. So as you can see in the table, if you only want to use one variable for prediction, so you are going to use simple linear regression. If you use more than one variable, you need to perform a multiple regression. And if the dependent variable is a nominal scale, a logistic regression must be calculated. If the dependent variable is metrically scaled, a linear regression is used. So whether a linear or a non-linear regression is used depends on the relationship itself. So in order to perform a linear regression, a linear relationship between the independent variables and the dependent variable is necessary. So here is an example of each type of regression analysis. As you can see, the one that are highlighted, or the variables that are highlighted in green color, are the independent variables, and the red one are the dependent variables. So visually, the relationship between the variables can be shown in a scatter plot. So in a linear regression analysis, a straight line is drawn in a scatter plot. To determine the straight line, the linear regression uses the method of least squares. So the greater the linear relationship between the independent variable and the dependent variable, the more accurate is the prediction. So mathematically, a linear regression is defined by the equation y equals bx plus a plus epsilon, where x is the independent variable, y is a dependent variable, a represents the y-intercept, b is the slope of the regression line, and epsilon is the random error term. So, as we recall, a or the y-intercept is the expected mean value of y when all variables of x are equal to 0. So on a regression graph, it's the point where the line crosses the y-axis. While b, which is the slope of the regression line, it refers to the rate of change of y as x changes. And the epsilon or the error term is the difference between the actual value of the dependent variable and its predicted value. So the linear regression equation always has an error term because in real life, predictors are never perfectly precise. However, some programs including Excel do the error term calculation behind the scene. So in Excel, you do linear regression using the least square methods and seek coefficient a and b such that y equals bx plus a. Now, here are the assumptions we need to consider if you're going to use linear regression. So, assumptions, if these assumptions are not fulfilled, we cannot into the payoff results of regression meaningfully. Therefore, we now take a look at these assumptions for the linear regression as follows. So first one, we have there must be a linear relationship between the dependent and independent variables. The error epsilon must be normally distributed. The third one is that there must be no multicollinearity or no instability of the regression coefficient, and finally, they must not be heteroscedasticity. The variance of the residual must be constant over the predicted values. So for the first assumption, in the linear regression, a straight line is placed through the data. So the straight line should represent all points as good as possible. If the relation is not linear, the straight line cannot be fulfill its requirement. So as you can see in the illustration, so the first one represents a linear relationship between the dependent and independent variables, while the second illustration fails to show a linear relationship between the dependent and independent variable. So it is not possible to put a regression line meaningfully throughout the points since it is not possible to coefficients of the regression model and it cannot be interpreted meaningfully. So for the normality distribution of the error component, we can see this one through analytical or graphic. So for analytical, we can use the Kolmogorov-Smirnov, wherein if given that our sample size is greater than 50, or Shapiro-Wilk when n is less than 50. So when p is greater than 0.05, it is normally distributed. And graphically, using histogram, we can observe that it is normally distributed if the data forms a bell-shaped like. And using quantile plot or the QQ plot, the more data lie on the line, the better. For the third assumption, no multicollinearity or no stability of the regression coefficients. So we're going to compute for the tolerance and the variance inflation factor. So the tolerance is the variance explanation once again and the varied explanation indicates how much the variance of x sub 1 can be explained by the other variables, and more it is speaks on the multicollinearity. If these variables can explain 100% of the variance of x sub 1, we no longer need x sub 1 in the upper equation. If the tolerance is less than 0.1, we have to be careful because in this case, we could have a multicollinearity. On the other hand, we have the BIF value and use calculated by dividing 1 by the tolerance, and we need to take note that we need to be careful if the value is greater than 10. So for the fourth assumption, we must look at the plot of the residuals. It must be in an homozygosity rather than heterozygosity. Now, let's know how to run regression analysis on different statistical tools. Now, let's be guided by this crafted research problem in which we are going to explore the impact of parental and infant sleep patterns on parental grumpiness. So, the aim of this study is to investigate the relationship between parental grumpiness and the sleep patterns of both parents and infants. So, the question will be, is there a relationship between the parental grumpiness to parents' amount of sleep per hour and the baby's amount of sleep per hour? Now, here is the guide in how we can run regression analysis using Microsoft Excel. Take note, we need to enable analysis toolpath. So, let's apply these steps in the Microsoft Excel software. In this example, we are going to do a multiple linear regression in Microsoft Excel. As you can see in our data, we have multiple independent variables. We have the parent's amount of sleep in hours and the baby's amount of sleep in hours. And our dependent variable is the parent's grumpiness. These data are collected for about 100 days. So, to start, make sure that your analysis toolpath was enabled in your Microsoft Excel. So, on the Data tab, you are going in the Analysis group, click the Data Analysis button and then select Regression and click OK. So in the regression dialog box, you can see that in the input part, you are going to indicate what are your Y range and your X range. The Y range refers to the dependent variables, while the X range are your independent variables. So first, let's have the Y range, which is the dependent variable, which is our parent grumpiness. So highlight, then click enter. Next is our independent variables. Since we have two independent variables, we are going to highlight the two columns. If ever you only have one independent variable, so you can highlight one column. So you have parents' amount of sleep and the baby's amount of sleep. And click enter. Now, since we include the first row, which is the name of our columns, we are going to select the labels. And then now in our output options, we are going to select the cell in which we wanted our results to be found, or we can add new worksheet file. So we have here, click this one and then click this cell and then enter. And then let's select or click OK. So here is the regression analysis output. As you can see here, we have the multiple R with a value of 0.903385619. The multiple R refers to the correlation coefficient, which measures the strength of the linear relationship between the two variables. So, in our case, we have the variables independent variables and our dependent variables. Since this value is near to 1, it shows that there is a positive relationship between the two variables, because it indicates that the larger the absolute value, the stronger the relationship. If it indicates negative, so we have a negative relationship. But if it is 0, then it means that there is no relationship at all. So in this case, we have a good fit since the multiple R is near to 1. Now, let's proceed to the R square and the adjusted R square. As recommended, adjusted R square is used if you're going to use multiple regression. R square refers to the coefficient of determination, which is used as an indicator of how of the goodness of fit. So it shows how many points fall on the regression line. So as you can see, we have 81.61% R square, and the adjusted R square is 81.23%. Now, the number of observations is 100, and the standard error refers to how goodness of fit measures the precision of the regression analysis. So meaning, the smaller the number, the more certain you can be about your regression equation. So, while R square represents the percentage of dependent variable variance that is explained by the model, standard error is the absolute measures that shows the average distance that the data points fall from the regression line. Now, let's proceed to the ANOVA table. So as you can see in our result, we have here the significance F, or the p-value. If we are going to consider the alpha, the level of significance 0.05, and we have our hypothesis, our null hypothesis, that all the partial slope are equal to 0, and our h1 is at least one of the partial slope are not equal to 0. Since the value of um, since our p-value is 2.14 raised to the power of negative 36, this means that the value of the p-value is less than 0.05. So meaning we we reject the null hypothesis and accept that at least one of the partial slope are not equal to 0. So we can proceed to our p-values represented by each variables. Now, as you can see here in the p-value, we have for the parents' amount of sleep per hour, we have the following hypothesis. So, when B, our beta, is equal to 0, or it means that the parent X sub 1, or the parental sleep, or the amount of sleep by the parents, has no significant relationship between Y and H sub H1, or H1, or the beta is not equal to 0, that means that X sub 1 has significant relationship between our Y, which is the parental parental grumpiness. Now, since our value is less than 0.05, meaning we reject the null hypothesis. So, there is a significant relationship between parental sleep, uh, parental sleep and parental grumpiness. Now, let's proceed to the second independent variable, which is the amount of sleep the baby has. So, we have the following hypothesis: beta is equal to 0, in which the x sub 2 has no significant relationship between y and H sub 2 or beta is not equal to 0, x sub 2 has a significant relationship between y. As you can see, the p-value of our second independent variable is 0.9691, which is greater than 0.05. So it means we fail to reject our null hypothesis. So there meaning there is no significant relationship between the amount of sleep of the baby and the parent's grumpiness. As you can see here in our upper and lower percentage, there is a big range between the two. And in the upper 95%, we can see that it is greater than 0.05. So here, in order to create the regression model, since we are going to ignore since the second variable is not significant, we have the regression model. Parental grumpiness is equal to our intercept 1.25 125.97 plus our slope for the parental sleep. So you have negative 8.950249,732. So that is how you are going to analyze your data in Microsoft Excel. Now, let's perform regression analysis in Jamovie. Let's apply these steps in the software itself. So, if you're going to use the Jamovie software in analyzing the data, so we're going to use the same sets of data. So now, you're going to, in the Analysis Data tab, you're going to click Regression. Next, select Linear Regression. So in the linear regression, you're going to determine the dependent variable, which in this case is our parent's level of grumpiness, and our covariance is our independent variables, which are the parent's amount of sleep and the baby's amount of sleep per hour. So as you can see here, it is reflected that we have an R of 0.903. So the same case in our analyzed data in Microsoft Excel. So this value is fit to identify the prediction of the amount of our independent variable and our dependent variables. And the same case with our results. So we have our intercept is 125.9656, and as we take a look at our p-value, only the parent's amount of sleep is significant to our dependent variable because as you can see it is less than 0.05, and the amount of sleep of the baby fails to have the significance relationship with our dependent variable. Further, so we can check the assumptions of our data here. So as you can see, we have the normality test. So as reflected, the Shapiro-Wilk, so it is greater than 0.05. So it is normally distributed and also visible in our QQ plot or the quantile plot of residuals. So mostly of our residuals are plotted on the line. And then in the model fit, we can see the adjusted R squared. So same goes with our result, it is still significant. Below also, you can see the ANOVA test. In the ANOVA test, you can see that the data are significant since it is less than 0.05. For the results and discussion, here is the guide in order for us to present our results and discussion. So using this guide, we can have the result and discussion of our sample problem. So it is stated, a multiple linear regression was calculated to predict the level of grumpiness, which is our DV, and of a parent based on the amount of sleep of parent and the baby, so which are our independent variables. A significant regression was found, F, in which F of 297, the 2 refers to the DF of the regression and 97 refers to the DF of the residual, equals the F value, which is 215.238, and P is less than 0.0 within an R square of 0.816. The parent's predictive level of grumpiness is equal to 125.965 minus 8.950 parents' amount of sleep were measured in hours. The parent's level of grumpiness decreases 8.950 for each hour of sleep. However, the baby's amount of sleep, P equals 0.969, is not a significant predictor of the parent's level of grumpiness. Thus, the parent's level of sleep is a significant predictor of the parent's level of grumpiness. So that concludes my report today. Here are my references. Thank you and God bless us all.